Okay, welcome to my students and learners. Today, very briefly, we are going to understand various level measurement techniques. So first we will learn the AR patch type level transmitter or level measurement. Okay, so you take one, for an example, you take one empty container like this and you take a tube like this. Okay, then you blow some air here, so very easily that air, it will pass through this because here is no resistance. But you think in the second case there is some liquid here. Now this liquid height, it will develop some pressure here. Okay, now the resistance is not zero, so you need some more pressure to pass the air and create the bubble. And if the level is further increased, you need more pressure. So basically, to pass the air through this liquid, then the pressure, the inlet pressure will vary based on the level. This is the main principle of bubbler type, or you can tell air patch type level transmitter. Okay, so this is a very simple arrangement. So this is a flow regulating valve. Here you can use some compressed air, and this is a tube. Okay, this tube is inserted till the bottom of the tank or container of which you want to measure the level, and with that one pressure gauge is connected. Okay, so now once you open this valve, first you connect this. Definitely this inlet pressure should be higher than the liquid pressure at the bottom with respect to height. Okay, so that means, say this pressure is P1. Now this maximum height is H, so the pressure at this point, if it is P2, so this P2 is H rho G. So what I mean to say, this P1 is definitely should be higher than that P2. Then only this air should pass through this, okay, and create bubble and come out. Okay, so now from this principle, it is very easy to understand that based on the liquid level, this pressure gauge reading will vary, and it's a linear relationship. Okay, even though there will be some losses through this line, that can be calculated. So you can connect, for that you can connect here one flow meter. One flow meter can be connected, and through that, you know that differential pressure, the differential pressure that is equal to some non-dimensional flow coefficient or flow loss. You can tell this is a loss into rho V square by 2. Okay, as per the Bernoulli's law. So now your V square is equal to 2 by sigma (2 by sigma into dP by rho. Now my discharge is equal to velocity into the aperture, the area, the cross section. So I can replace it. So my Q, so V is equal to Q by A. So my Q square is equal to 2 by sigma A square into dP by rho. Okay, so my Q is equal to root over A times root 2 by sigma into root over dP by rho. This term, it is called the flow coefficient. So through this also you can find out the because this inlet pressure will be known, and if you can calibrate this flow, then you can find out this pressure also, which is directly proportional to the height of the liquid or the level of the liquid. So by calibration you can measure, you can establish the relationship between this pressure gauge reading, and this height. So for you can apply a certain pressure and open this valve, so that till the bubble is created, and then you can make a chart. So this is my pressure gauge reading and this is my level, and you can take few readings. So this is when the level is bottommost. So when the level is bottommost, so this will be this pressure gauge reading will be 0. Then you increase some level like this, then it is P1, your level is L1, then P2, level is L2, and so on. And with this relationship, it will be a linear relationship. With that you can find out a linear equation. H is equal to, or the level is equal to, a function of this pressure. It's a very simple technique and you can use it. This method, one small experimental setup can be made and you can use it. Okay, so this is called the purge type or bubbler type level measurement. This is the basics of purge or bubbler type level measurement. Now coming to the radar type level measurement. In this level measurement, it's a non-contact type level measurement. Say the liquid is very hot or it is highly corrosive, it's creating some vapor. Okay, so these cases we can use the radar type level measurement. What is this? The radar basically used the radio wave, electromagnetic wave. So here you can use one in the top of the tank or the container. You can use one receiver transmitter system. Okay, now say the level is here. Now say the level is here. So this will transmit some radio wave. It will come and again it will reflect back and it will go to the receiver. So this is my transmitter and this is my receiver. Okay, so the time we have to, once we created a pulse, we are triggering the transmitter, the counter should start. Okay, and once the reflected signal, that is called the echo, because here there will be a difference of density, so definitely the signal, the electromagnetic wave, it will reflect it back and it will come to the receiver again. Say that T is equal to T1. So you got the time, this time. So this T1 is the time which took to travel from here to here and again here to here. Okay, so the time of flight you can calculate like this. Now the time, the level, so if you know the, because this electromagnetic wave it travel with the velocity of light, so if you know the velocity and then the time, this time of flight by 2, this is your instantaneous level. Okay, now the thing is this angle, because when you are generating the pulses, this angle, it is called the time of diversion angle. So this angle should be as low as possible, otherwise you know this will be this will be spread out, and while you are receiving it, the intensity of the receiving signal, the echo signal, will be less, which can cause some error in the measurement. As well as the dielectric constant of the liquid also should be high enough so that the attenuation is, this means the absorption is less, otherwise this also can cause some level measurement error. So to and say this liquid is creating some vapor, or it is this will create some layer, it is evaporated and deposited on the receiver transmitter or something like that, then this also in turn can reduce the intensity of the signal, which also can cause the error in the measurement. So for that you can use some guided tube or guided one rod, simply here you can use. So by using that, what will happen, so first case it was non-contact type, but it will be in contact type. So when this electromagnetic wave will travel through this rod and once the level is here, and then that the impedance of propagation will vary based on the level of the liquid, and your time of flight will change accordingly, and you can also get the level measurement. Okay, so this is basically very simple. These are the very simple techniques. This is the radar type level measurement. Another type of level measurement, it is ultrasound level measurement. So ultrasonic sound, sonic means which we can hear, that is 2 Hz to 20 kilohertz. This is the range human ear can detect this sound. But if it is beyond this 20 kilohertz, this is called ultrasonic. The human ear cannot detect that. Okay, so this is also same, this technique also same. So earlier case it was this for radar type, this will use the time domain reflectometry, time domain reflectometer, using that. So here also this ultrasound receiver, same way the ultrasound receiver transmitter can be kept. Okay, so this is the conventional this setup, it is available in my lab, it is calibrated also. This sensor name is SCSR04. So this is the pin, this will operate 3.3 to 5 volt logic. So here is the, you can connect the 5 volt, okay, and here the ground, and this is the trigger pin. You can give a square pulse, and this is the echo pin. You can receive this, you can receive the raising edge of the, after reflection, once the signal is received by the receiver, then you will receive one echo here. You count the raising edge. So once the once the pulse is given in the trigger pin, you start the counter, and once the echo pulse received in the triggering pin, again you detect the raising edge. Okay, so this trigger pin can be this echo pin can be connected to the interrupt of the microcontroller, and there the interrupt sense can be set as raising edge, and once you can detect it, you find out the time difference between the triggering, when the triggering started, and the receiving of the echo, and through that you can find out the time of flight, and based on the same earlier principle, radar principle, you can find out the level. So this time of flight, these things coming, starting from the transmitter, coming to the liquid level, reflected back and going to the receiver, this time is called the time of flight T1. If you can find out that one, then you can find out the distance of this height. This height, if it is h, so this h is equal to velocity of ultrasound into time of flight divided by 2. Okay, so now my total height of the tank, if it is capital H, so my instantaneous level is equal to h small h minus capital H minus small h. So this is the very briefly I have described the, you can implement, as I told, this all kind of level measurement technique is implemented in my lab, and we have calibrated it, okay, using these sensors. These sensors are very, because it's a demonstration purpose, not for industrial purpose. Industrial purpose, we have to do lot of other we have to take in a lot of other things are to be taken care. So this kind of things, one setup is all for parts type, for bubbler type or parts type, then for that radar type and ultrasonic sensor type. All these three types of sensors are available in my lab, and we have calibrated, and it is giving perfect level measurement. So hope this is a very simply I have explained without going to the details and its implementation. So hope this video will be useful to you all. In case of any question, you can ask me. My contact details will be there in the description. So hope this video will be helpful for your day-to-day life and your working life also. Thank you so much. Thanks for your patience.